Bare vil vise litt om hvor vi i den reisen selv hos Alab. Jeg representerer Alab arkitekter. Vi basert i Oslo. Vi jo 100 stykker som sitter rundt alle mulige typer størrelse og markedssektører i Oslo. Vi også en del av det multikonsult-paraply, som har lært oss til å jobbe tverrfaglig mer og mer. Så jeg veldig glad for å ha den mulighet til å utvide vår kunnskapsmangfold, for å si det sånn. Oh, sorry, I was thinking to warm you up for Stefan in English. Ha, I forgot. I was last week in this artificial intelligence conference in Finland, where Stefan was actually giving a keynote. So you are in very good company. A lot to look forward to hear from him. But the takeaway from the conference for me was this picture. You can actually find the YouTube video where the guy from Top Gear decided to test one of the MIT robots to carry the oldest of carriages that he could get his hands on. And as you see, it works, but it's definitely not the most effective thing to do. And for me, this represents what architects are trying to do with artificial intelligence technology today. We are trying to put something that could be a game changer, a really new and innovative technology in front of old and outdated processes. So I think that we need to do a lot of soul searching as architects about our role before we can be a serious part of this dialogue. It's going to raise a lot of philosophical questions about our profession, and by all means, bring them on. So imagine that this was 2020, to just find the simplest example of how far we have come in such short time. This is a job that it's very repetitive, that it doesn't require any particular skills. And then, of course, 5 years later, you have almost every single garbage sortering operated by robots. And of course, these robots are guided by the invisible hand of artificial intelligence. I wanted just to discuss with you, so we have this common understanding on what is really an AI system. So I wanted to use the same example of the garbage picker to try to understand where in this model we fit, where can we improve it with our unique value proposition as architects. So if you think that the AI system is the whole garbage picking service, the first thing you have is the use case, right? So in our example, we want to sort materials, some for recycling and some for disposal. Now, how is this artificial intelligence system going to learn? Well, we have to give it input, which is data of pictures of other kinds of garbage, so it can learn what to pick, what to separate, and so on. Then it comes the machine learning module in the AI system, which is what is going to take this information from the pictures and decide what to pick and when to throw. And last but not least, you have a software applications, which is the interface that actually will guide the robot. So somewhere in this in the system, we have a lot of decisions that we make, and this input that we're giving to the system is crucial. Because behind the data that we are using to train this model, there is a lot of decisions that have been made by people. And this is what we call in artificial intelligence labeling. So we are saying, identify these objects and create patterns out of it. And it's actually pretty straightforward to the point that the artificial intelligence system starts learning by itself, because it recognizes that more or less on that size, on that kind of color, you have things that are possibly plastic or garbage and so on. So this exponential learning of this AI system, it's very important. And this data labeling industry is expanding. It's to billions and billions of dollars. There is a lot of people in countries that are sitting down and deciding what kind of information is going to be feeding the artificial intelligence model. And there is where the key comes for us as architects. If you are labeling, in this example that we have here, for example, dogs, right? It's so much about your own meaning that comes through that it's going to be used for further analysis and making decisions. So for you, a dog is a mammal, is carnivore, it's just a dog, it's a working dog. What kind of dog? And all these human input that goes into teaching the model, it's very important. So imagine what this means for us as architects. If we're going to be labeling information to train an AI model, are we going to be saying what is good architecture? What are the qualities? What do we want to do more of, less of? It's going to require that we take a deep breath and really study what we're proud of in our work, in our catalog of work, and be really, really accurate on what are the things that we want to bring into the next generations of buildings. So for me, the kind of building data that is necessary to really support this system in the future, it will vary depending on your client, on your profile in your office, and even in the project itself. But the most important thing is that we transform all this data that we are generating as we design and connect it to insights. So the data becomes information, and down the line, we can use AI models to help us find those insights faster and turn that knowledge and that information into knowledge. And this is an example of what labeling could mean in architecture. So let's say that at A-Lab, we work a lot with really large urban developments. And when you are in the early phase, the sky is the limit. You have the possibility to test all your options. But how do you input generative design based on typologies that you trust, that you have tested? So this is an example on how you can create some conditions. In the left, you see that there are some typologies of housing that you want to test. So in total, there are 38 different tiles. And on the right side, you can see how these tiles could be positioned in all different rotations. And then what we ask the artificial intelligence input is to read some success criteria. What is the percentage that you need of green areas? What is the targets that you have for minimum sizes of the streets in between and so on? And then it creates a combination of variations that you have created. So in this sense, it helps us keep optimizing, seeing what works and what doesn't. And the big question here is, how do you trust the outcome? In my personal opinion, what is going to be challenging for architects is to make the difference between parametric design and artificial intelligence. Because these two, let me play it, these two images that you see here in parallel, they are both automating a lot of design processes that we always do. We normally do simulation according to microclimate, crowd simulation, and so on. And then you set up some targets. The picture in the left is simply based on Grasshopper scripts, where we have full control on what data goes in and what data goes out. The picture on the right side is showing you the Forma, the Autodesk Forma AI model, where you can actually use the microclimate simulation to create options that will satisfy your success criteria for the project. But the challenge that I see for us as architects is that we are suddenly expected to work using the AI tools, but if we haven't gone through the process of going from parametric design into computational design and then generative design and so on, you see here the evolution of different ways of using data to create automated design. And it's going to imply that we skip quite a few steps. If we haven't been developing good practices for parametric design and computational design, suddenly you will have a very steep learning curve. So parametric design for me is very important because it helps us understand how geometry behaves based on patterns. And those patterns are the input that we're going to give to AI models. So if we haven't done our homework of understanding all these different design possibilities, I would encourage you that before even looking into artificial intelligence, understand properly the principles behind parametric and computational design. There's another aspect of AI that has been, of course, very attractive for architects, and it's the text to image, the possibility or the promise of exploring your design on a record time. And then you see all these beautiful, crazy pictures that are thrown around everywhere, and Donald Trump riding a unicorn into the sunset and all these things. Well, this is crucial for us because communicating our design is one of the most important parts of our work. So I wanted to show you just a little bit of what's the principle behind this kind of generative image generation. And it's really not magic, and it's really not out of reach. It's simply understanding where we need to give input and have the right possibility to control the outcome. So for example, when all these beautiful stable diffusion images that you have seen, the process is very simple. You take the original image and it's called adding noise, which basically in our world, it means just pixelating, lowering the resolution of the original image more and more to the point that the cat on the right side could be a cat, but it could almost be any animal. So you just have to make sure that you add enough noise to expand to unlimited possibilities of what that picture could turn into. And then you bring into the text commands, right, what we call the prompts, and start with language giving input on how this picture should be recreated from that pixelated version to look closer and closer to your intention. So we go from like, I don't know what's the race of that cat, but like a realistic cat, and then you start modifying the image and giving it instruction until it turns into this very cool cat with glasses, right? And just for that is said, I see that the next generation of architects don't have a lot of the constraints that we are used to as experts. These two guys are Erlen and Espen. They are my favorite architectural students in Norway. They are in NTNU right now, and they also are practicing in Hilemelby. And they decided that the technology has come so far that it has actually removed a lot of the constraints that we have in the way how we approach design as architects. So they decided that the best way to go about it was to start exploring artificial intelligence. But they very quickly understood, as you see, this is a snapshot from their presentation, because they were also on the seminar in Helsinki. I was very proud to be part of that process. Seeing young people take technology and turn it to their advantage, it's very inspiring for me. But they quickly understood that just to take an off-the-shelf AI technology and plug it into their way of working was not good enough. The output was very stiff, was unreliable, and unrelatable. I see also when some of my colleagues try some of these tools, they say often shed in, shed out. It has become a very popular expression. And it's because we don't trust what's happening inside the AI model and where these things are coming from. We had a similar process when we started using simulation, because you need to really understand where the metrics of microclimate simulation are coming from to be able to explain them. And it takes a lot of courage to be in a client's meeting and stand behind all these design ideas that we present. So when they are coming from places that we don't understand, we feel uncomfortable. So these two young architects, what they did was that they identified that what was missing in the off-the-shelf solutions was that they were not having control and they were not having enough dialogue with the solution. So they created plugins and web page applications where you connect the existing technology, but you give possibility to have more control through, for example, reference images and also a dialogue. How can you encourage? Because artificial intelligence is not a one-way stream. We have to talk to it. We have to engage with it so it starts producing the results that we want. And also, you teach it as a child by asking questions, by navigating what kind of knowledge it should take in. So what they did was to not be dependent on somebody to develop a tool that they like, but they decided to program and build the tools themselves. So watch out for these young architects that see technology as an advantage and not as a threat anymore. These are the people that are going to be making all the decisions in the industry 15 years from now, and they are not afraid of this. So my question for you, because more than a solution, what I can present you is a question on what is it going to take for us as architects to actually open up this black box, understand what is inside artificial intelligence and how we can have a meaning about it. Because from the labeling, deciding what is good architecture or bad architecture, we want to be part of that process and really help to give this thing direction, because we are already using it in generative design for the big projects, using simulation, inputted back, having controls of the targets. We are using it to create automated apartment mix and office layouts that can give us a lot of insights earlier. And of course, creating catalog of information that we can reduce and is adaptable and smart. Because as architects, I experience that the clients sometimes feel that we work for a very long time on the wrong premises. And then corrections get very expensive and they get frustrated with the results. So the way how I see it, these tools that we're using is in order to identify if there is room to work more efficient or to realign the project with new goals or new success criteria. So that's what I had. And thank you so much for listening. If you want to get in touch with me or with the students from NTNU, it's just to reach out. You know where to find me. And thank you so much, and enjoy the rest of the seminar. You are in for a treat with Stefan now. So thank you for having me, Born.